All right, hey guys, Mr. Kyle, Myers Mathematics, and today will hopefully be the last of 3 days or three videos on this topic, the Envision 2020 Geometry Topic 1 Solutions. So this is now getting towards the end of Topic 1, and since I also do tutoring, and you can sign up for tutoring in the description below, I've noticed some of my students are at different places because of different curriculums and private versus public and that sort of thing. But I noticed a lot of people are getting towards the end of Topic 1, and so this will hopefully be helpful for you right now as you get to the end of this, or if you're watching this a year later and you need the solutions to the Topic 1 geometry. Basically, Chapter 1, Topic 1, same thing. So without further ado, let's go ahead and dive into the last page here, which I believe is page 67. And we'll zoom in here and look at our problem. So the third to last section, they kind of groups lesson 1-7 and 1-8 together. So sort of the second to last here is deductive reasoning, which if you watched the video before, or if you've been paying attention in class before, inductive is when you're looking for patterns. So it's sort of like, hey, I'm going to look for what seems to be the case and just say like, oh, hey, I think this is a thing. Versus deductive reasoning is sort of the opposite. You sort of start with, okay, what seems to be what's true, and then the pattern should follow. So it's sort of reversed. It's like I'll look for patterns and then come up with a claim. Deductive is like trying to get to the claim first, and then you say, okay, well, if this is true, then all these patterns should follow about this thing. So it's sort of reversed. There's two little vocab words, law of detachment and law of syllogism. Law of detachment is just this, interesting law where if the first thing is true, if P is true, then Q is true, which basically would be something like this. Like if I said, all dogs have 4 legs, right? Assuming that we're just not counting, if a dog loses a limb or is born without a limb or something weird like that. Like that's a kind of an anomaly. Most dogs have 4 legs, so we'll just say that that's true for a second. So all dogs have 4 legs. We'll assume that's true, and then if I write that as a conditional, it would be if it's a dog, then it has 4 legs. Okay, so then I see a dog, and then what must happen? It must have 4 legs. Okay, so that's basically what law of detachment is. It's sort of like this no-duh law that they decided they needed to teach you with a vocab word. So I'm sorry, but I figured I'd mention it because you want to kind of make sense out of what it is for a vocab quiz that might be coming up or something like that. So law of syllogism makes a little bit more sense. It's basically another word for it is the transitive property. And you can also kind of do, at least in equations, you can do a substitution property instead. So basically, if P goes to Q and then Q goes to R, then P goes to R. That you could connect them. Law of syllogism says you can connect the two things. So if I say, for instance, if today is Tuesday, then tomorrow is Wednesday. Okay, well then, if tomorrow is Wednesday, then the day after that would be Thursday. Right? So, and again, all of these things are normally like no-duh kind of statements. So if today is, in fact, Tuesday, and at the time of me doing this video, it is Tuesday, then the day after tomorrow would have to be Thursday. That's what I just, instead of saying Wednesday, I just cut out the middleman and went straight to Thursday. So that's all they're saying for law of syllogism. Another way to remember it is the transitive property, which makes more sense, I think, because the prefix trans means to move, like transportation, to go from A to B, right? Or translate, to go from language A to language B. So that prefix means to go from A to B. So here it's like, okay, well, you go from A to B and then you go from B to C. So really we're going from A to C, right? You're traveling. Let's say you need to go to work and you want to stop at the Burger King before work or something, I don't know. So it would be like, okay, Burger King is the stop B, but ultimately you're getting to stop C. So anyways, let's go ahead and dive into number 41 here, now that we've got the vocab out of the way. If AB equals BC, then DE equals 2AB. Okay, so AB equals 6, and BC equals 6. What can you conclude? Okay, and we assume the given information is true. That's the prefix or the subheading there. So, okay, so AB equals BC. Let's just kind of write this out here. AB equals BC. AB equals 6. And BC equals 6. Well, yeah, that makes sense. If AB equals 6, then BC would have to equal 6. They didn't even have to tell us that. So I just replaced AB with 6. Okay, cool. So then DE equals 2AB. Okay, well then DE equals 2 times AB, which is 6. I just substituted a 6 there instead of an AB. So that means DE must be 12. Right? Not too crazy. You just kind of plug it in. You just plug in the thing. All right, so that's the answer to 41. And then 42, I'm going to move this over a little bit more so I have some more space over here. 42, and actually I'll probably just erase this here. 42, if it is a sunny day, the water park is filled with people. If the water park is filled with people, the lines for each ride are long. Use the law of syllogism to write a true conditional statement. All right, so if sunny, let's say this is P, water park, then the water park is filled with people, that would be Q. If the water park is filled with people, again, Q, that's the same exact thing going on over here. That's Q again. The water park is filled with people. The water park is filled with people. Yeah. All right, got it. The lines for each ride are long. That would be the R thing. So, if it is a sunny day, then the water park is filled with people, and then if the water park is filled with people, then the lines for each ride are long. And there we go. You just cut out the middle. That's all you do. So there we go. That's the syllogism thing. And then 43. Communicate precisely. An advertisement says if you use their toothpaste for more than a week, you will have fresher breath. Yum. You use the toothpaste for 10 days. If the advertisement is true, what can you conclude? This would be law of attachment, which is sort of like a no-duh kind of law. So they're saying an advertisement says if you use their toothpaste for more than a week, how much is a week? A week is 7 days. So more than a week would be 8 or more days. You use the toothpaste for 10 days, which is 8 or more days, so we can conclude that we should have fresher breath. Should being the key phrase there, because you never know if you had lots of onions or something. Should have fresh breath. There you go. Save money on breath mints. Okay. Next section, which is the last section or sections, lessons 1-7 and 1-8. So in these sections, I noticed they didn't say too much about different kinds of proofs. They mention, at least in the book, a paragraph proof, but there's also something called a flowchart proof. And they don't really do a whole lot with those. But you will need to know how flowchart proofs work and two-column proofs work for the end of semester test, most likely unless you're in a private school and they don't care about one or both of those kinds. But you'll most likely, at least for public school, need to know how flowchart proofs work and two-column proofs work. But you only need to know how to fill in the blanks. You only need to know how to do like a drag and drop or to do a multiple choice or something like that. So you don't need to like build it from scratch. But if you can build a proof from scratch, then you can definitely fill in the blanks. So I would say try to see if you can make a proof from scratch. Like take one of the proofs and then just don't look at the statements and reasons and try to do it all yourself and see how close you are. I would highly recommend trying that just to kind of get an idea of what that's supposed to be. And then that way you can fill in the blanks a lot better. Okay? So it says for 44, find the value of each variable and the measure of each labeled angle. So these two are vertical angles 44 and 45 both, they're vertical angles. So that means that they are equal. So that means for 44, 3x minus 6 equals 2x plus 22. And it says find the value of each variable, so x, and the measure of the labeled angles. So we're going to plug it back in and figure out what they are. And the cool thing with this is you can actually plug it back into both, and you should get the same answer. So that'll be helpful. We're going to subtract 2x on both sides. Do that first. Subtract 2x. So this is x minus 6 equals 22. And then I'm going to add 6 to both sides. I always combine the x's first. I noticed that if you combine the x's first and then the numbers, it always tends to flow better. So I would highly recommend combining your x's first and then combining your numbers. But I get 28 for x here. If I plug it back in, I should get the same number for both. So 28 times 2, I just double it, so it'd be 56 plus 22. And that's supposed to equal 3 times 28. And let's see, 3 times 28, that's I was about to say 4, and then I wrote 2. Goodness gracious. So 3 times 28, 3 times 8 is 24, carry the 2, 3 times 2 is 6, plus 2 is 8, so I get 84 minus 6, and that would be 78, and this would also be 78. Oh, look at that, we get the same answer. So highly recommend, if you have time, to plug it into both. That way you know for sure that you have the right angle there. Right, so that was 44, the answer is 78. Next up is 45. The only thing funnier than 44 is 45. 45, here we go. So same thing, they're both vertical angles, and I know they are because they're across from each other, and if they're across from each other, they're vertical angles, and by the vertical angles theorem, we know that they are the same angle. So 2x plus 32 equals 3x minus 5. Okay, so this one actually works out really well, just like the last one. I can just subtract 2x on both sides. So that happens. And then I get 32 is equal to x minus 5. Notice I put the x's together first. Pretty much always do that. It just makes more sense to do it that way. And then I'm going to add 5 to both sides, so this will be 37. Right? And then, of course, we want to check. So we want to plug it in. 37 doubled would be, let's see, 74 plus 32 equal to 3x, so 37 times 3. 3 times 7 is 21, carry a 2. 3 times 3 is 9, plus 2 is 11. Look at that, 111. Crazy. All right, minus 5. So then I add these guys up, and that's a 6, and that's a 10. And if I subtract those guys, it looks like I get the same thing, 106. So there we go. Done and done. They're both 106. All right, so then we have 46. It says write a proof. So again, I'm going to go ahead and write the proof since, challenge accepted. But you don't normally have to know how to write proofs. You normally have to know how to fill in the blanks. So just a heads up there. So write a proof. Given measure of angle TUV is 90, prove that x is 12. Okay, so both of those little pictures there are part of the same proof. So we know that TUV is 90, right? So that would mean that this is a right angle. And then we have y here and 42 here. And then we have this other little diagram here. And we know 4x is here and y is here. Okay, so before we try to write this as a proof, let's just treat this like a regular problem. So if this is just a regular problem, then what we would do is, they're saying prove x is equal to 12. So let's find out what x is. Let's see if x is actually 12, starting from what they gave us. Right? So if we don't know that x is 12, we're not going to assume that x is 12. We're going to just assume what they gave us. So we know that these two things add up to 90. So by the segment addition postulate, I can add y and 42 and get 90. Right, segment addition postulate, back from topics 1 and 2 4-ish, depending on your book. But this book, I think it's in topic 1. So if you add 2 pieces, you get the whole thing. So boom, that happens. 42, 42, I'm going to subtract and solve for y. And this would be, I believe, 48. Yeah? Make sense? Subtract 48. So y is now 48. Okay. So if y is 48, then that means that, and we also know 4x is equal to y, because those are vertical angles, right? So then I can plug in 48, and that's equal to 4x, and then I divide by 4, and x is equal to 12. Look at that. That is true. Okay. So in order to actually write the proof for this, I'm going to move this over, and we'll do our statements and reasons over here. Okay. So statements, reasons. I like to be a little lazy sometimes, so I just put an S and an R. But if you have to write a proof, you should probably write it all out. Don't follow my example. Just kidding. But yeah, so statements and reasons. So SR, statements, reasons. We know we're given the pictures, which you can't really say given the pictures, but we can say that this angle here is 90, and that was TUV. So TUV. TUV. And then the other thing is W. Okay, that's all I needed. Now I can do the proof. This is W. That way we can give appropriate names. So we want to say that TUV is 90. You always want to say what you're given first and then kind of just go from there. So measure of angle TUV equals 90 degrees. Reason given. Okay. And there's only 5 kinds of reasons, by the way. There's given as a reason. There's postulate or axiom. There is definitions. Okay, that's one kind. Theorems, which are what we're doing right now. We're creating a little mini theorem, or vertical angles theorem as an example. You can use that later on as a reason in another proof. It's like proofs within proofs. It's proofception. So we have those. We're at 4 now, and yes, I know I'm counting weird. I count like a German. So we have, oh, I'm missing laws and properties. So laws and properties kind of go together because they're kind of interchangeable sometimes. But properties, they're usually called properties instead of laws. And then you have definitions, theorems, given, and did I say postulate already? Yeah, there's 5. So I won't write them down, but yeah, if you didn't catch all those, you can go back in the video and grab those. They're really, really important, and it's really helpful to know that there's really only 5 reasons, because it can seem a little overwhelming sometimes at all the reasons there are. But if you don't see one of those 5 things in the reason, it's not a real reason, and they're trying to dupe you. They're trying to dupe you, so don't be duped. So given measure of angle TUV is 90 degrees, we can now say that TVU, so if I add, so that basically you just follow your work. So measure of TVW, oh, TUW, it looks like a U anyways, plus measure of angle TU, or sorry, I already did that. I want to do WV equals the measure of angle TUV. And notice I didn't say 90 yet. You could maybe get away with doing that, but you're kind of skipping a step. So I'm going to be very methodical, because you could maybe skip a step or 2 if you're watching this and you're in regular geo. You don't necessarily have to get all the steps perfectly. But yeah, so we would actually technically say this next. And this is true because of segment, or sorry, not segment, angle addition postulate. Angle addition postulate. And then we can say measure of angle TUW plus measure of angle WUV equals 90 because of either substitution or whatever you want to call it. So sub T property, subtraction, or sorry, substitution, I want to put an S here. Substitution property. So we're substituting 90. Okay, so then next we would want to say, okay, well, we solved and we got y is equal to 48. So we know, okay, well, measure of angle. So then we could say y plus 42 equals 90. Again, substitution property. So I'm actually going to just leave this blank because it's just the same reason for both, even though it's two different statements. So I'll just leave it there. So same thing, substitution property. And then we can solve and get y is equal to 48, and we did that by subtracting on both sides, and that is subtraction property of equality. And I like to abbreviate PO because I played a lot of Legend of Zelda growing up, and it was fun to try to collect all the POs. So I like to call them POs. Sub-T-PO, subtraction property of equality. Anytime you do something to both sides of the equation, it is a property of equality, and you just name it thusly. So anyways, we have y equals 48 now. And then we also know that 4x equals y. Okay, we know that 4x equals y because of vertical angles theorem. We know that those are the same because of vertical angles theorem. And therefore, 4x equals 48. Again, this is subtraction property. I'm going to kind of scroll up a little bit here. So, sorry, substitution property. And then I need to divide both sides to solve. So since I had to divide both sides to get this, that was because of the division property, divipo, division property of equality. So again, when I abbreviate, your teacher may or may not like you to use the same abbreviations that I use. I like to use very strong abbreviations because why not? And it's fun and it sounds fun to say VAT, V-A-T. But just note what your teacher wants and what they are usually putting for reasons and statements and things like that, so that you can get an idea of what they're looking for the test. Okay, but that's what I would put. That's what I would do, and that is how you fill in and make a proof for number 46. So if you didn't grab that in time, you can just go back in the video. It's magical. You just press the back thingy button on the video, and you can go back and check it out there for that reason there. And then number 47, it says write an indirect proof by proving the contrapositive. By proving the contrapositive. Okay, so here's what we're going to do. These indirect proofs can be kind of tricky, but they tell us exactly how to set it up. So one of my favorite proofs is the reason why the square root of 2 is irrational. It's one of the first proofs that you learn when you first get into real big boy proofs in like big boy math classes in college. And you have to do it by contradiction. You actually assume that the square root of 2 is indeed rational, and then you prove that that's wrong, which is what we're doing here. If you want to prove that the square root of 2 is irrational, then you would say, oh, well, let's say it's rational, and let's find out that that's not true, and therefore the opposite has to be true. So we're going to do the contrapositive. So in order to do the contrapositive, it might help for me to write this first as its contrapositive. Let's first write it as a conditional statement, so you can see exactly what they're asking here. So I'm going to move my little text box over, and we want to say if I put L. If Gj is equal to 48, so the given is the if, and then the prove is the then x is not equal to, so I'm going to put this because it means not, since I can't do an equals and a slash through it, then x is not equal to 12. Okay, if Jg is equal to 48, then x is not equal to 12. That's what they're saying. So the contrapositive, let's see if we can write this here. Let's move this. I want to move this text box. Okay. So now we want to do the contrapositive. Remember, contrapositive is the converse and the inverse. Converse from either last week or the week before, that's the shoes. Right? Converse shoes, high tops. If you put your left on your right and your right on your left, your shoes are going to fit kind of funny. Right? Now, if it's a bike conditional, it would be like Converse socks, I guess. But converse shoes, put the shoes on the wrong feet. Left on the right, right on the left. Okay, so you switch the statements, but you do not negate them. That is for inverse. Inverse is inverse, like the letter in, verse, in for not. So it's the not verse. You don't flip, you just negate. So you just make it the opposite of what the hypothesis and what the conclusion are saying. But contrapositive is both. It's the converse, flip them, and the inverse, negate them. All right? So, you see my hands? Left, right. Left, right. I feel like I'm doing some sort of thing here. All right, so left on the right, right on the left, and then you flip them over. The individual things. So, if x is indeed equal to 12, then Gj is not equal to 48. Okay. So if Jg is equal to 48, then x is not equal to 12. That's what they're saying. If I flip it and negate it, I get if x is equal to 12, then Jg is not equal to 48. So that is what we are trying to do. Now, our given is that x is 12. Right? So notice I flipped it and negated it. So now my first thing, x equals 12, that's the new given. And then what we're trying to prove is that Jg is not equal to 48. Okay? And the reason why we can do this is because the contrapositive actually has the same truth value that a conditional statement has. It's this nifty little thing you can do. So I'm going to get rid of the original conditional, and we're just going to roll with this guy. And I'm going to move him over here. And then I'm also going to rewrite this picture, and then that way we have room for our proof and our work and stuff. So we have G all the way over. Let me try to make a straight line here. G all the way over to J, and somewhere over here is H. That's x, and that's 2x. Okay, so that's our stuff. And we want to say, okay, would Jg be equal to 48? Well, let's find out. If x is 12, then it would be 2x plus x equals the whole thing, right? So 2x plus x would be the whole thing, aka 3x. And x is 12, so it would be 3 times 12, which is 36, not 48. So we basically just did the whole proof right then and there. The whole proof just happened. Now we just write it into statement and reason form. Statements, reasons. Okay, so statements and reasons. First, we want to state that x is equal to 12. X equals 12. Reason, given. Okay. Then now remember, we're trying to get to the fact that Jg is not equal to 48. Okay. So let's start with segment addition postulate, because we need to add some segments. So we would say GH plus HJ equals GJ, and that is segment addition postulate. Okay. Now we want to plug stuff in. So we know 2x plus x equals GJ, and that is because of substitution property. And then, of course, 3x would equal JG. That was the next thing we did. And this is not actually addition property of equality. Okay, you have to be really careful with this. We didn't add something to both sides. If you add something to both sides, that's addition property of equality. If you only add stuff up on one side, that's actually just substitution property. Okay, so be really careful with that. Okay, so 3x equals GJ. And then we can go ahead and plug in our x. So 12 GJ. Again, just substitution property. We're just substituting things, okay? And then 3 times 12 is 36. Again, not multiplying on both sides, just multiplying on one side. So again, that's just substitution property. This is all just substitution property. Now, since 36 is equal to JG, that means that JG is not equal to 48. Okay, if a number is equal to another number besides 48, it cannot simultaneously be equal to 48. And this would actually be kind of a different thing than maybe you're used to seeing so far. When something is not equal to something else, this is actually the law of non-contradiction. Okay? The law of non-contradiction. So you might be thinking like, oh, how was I supposed to know that? Well, remember, if you are supposed to know this for your particular class, your teacher will, if they're pretty awesome, at least a little bit awesome, then they'll let you know, like, hey, this might be something that comes up on the test, so you need to know when something is not equal to something else. That's called the law of non-contradiction. But if you're like most people, it doesn't matter that much because you're just going to be filling in the blanks. So you're just going to be filling in the blanks with things that you need to go there, okay? But it is good to know what that is. It just means, hey, if something is equal to something, it can't be equal to something else. It's actually this really, really basic law. It's basically like a postulate, like an axiom, okay? So also notice that we only use 5 different reasons, like I was saying before. We have given in this one, and we have postulate, we have property, and we have a law, which is also sometimes called laws are sometimes also called properties. So the only thing we missed in this particular proof was a theorem. We didn't use any theorems in the reasons, okay? Those are only 5 givens. So I hope that helps. And that actually brings us to the end of this thing. We finally finished everything. Yay! So I hope this has been helpful and this helps you to get ready for the test if you are coming up on the end of topic 1 test. So I hope this is super, super helpful for you. And yeah, if you haven't seen the videos from before, I'll put the links for those in the description. And go ahead, like, subscribe, and see new videos like the one I'll be doing next Tuesday at the normal time that I do. And if you haven't gotten my free guide, which is the 5 math mistakes everyone makes and how to avoid them, it's awesome. You should grab it. It's free. It's on my website, myersmathematics.com. Also in the description below. And I'll see you in another episode real soon.